Welcome, everyone. I'm excited to kick off our presentation today. Today, we're going to explore UNITIII, which is all about airport planning. This is the first slide, so I just want to briefly introduce what we'll be covering. We'll look at the fundamental concepts of airport planning, its importance, and some key aspects involved. So, let's get started and delve into the fascinating world of airport planning. Air transport is actually the most recent mode of transport to develop, and it's often considered a gift of the 20th century to the world. What makes air transport really unique is that it doesn't require a specific surface track like roads or railways. Unlike other modes, it can operate without physical barriers such as mountains, rivers, or even political borders. This means that once an aircraft is in the air, it can easily cross boundaries that would otherwise be obstacles for land or sea transport. Of course, it has to follow international laws and regulations, but overall, these borders don't pose a major physical barrier. The biggest advantage of air transport is its incredible speed. It's by far the fastest mode of transport available. This quickness makes it ideal for urgent deliveries, whether it's passengers, mail, or light, high-value cargo. However, all this speed comes at a cost. Operating an aircraft is expensive, so air transport tends to be accessible mainly to wealthier passengers or for specific goods that justify the higher price. Despite this, in countries like the United States and Germany, air transport has become a serious competitor to railways, especially for certain routes and types of cargo. So, in the context of overall transportation development, air transport's speed and flexibility have really transformed how the world moves people and goods across long distances. Let's take a closer look at the characteristics of air transport. First, it offers an unbroken journey, meaning it can cover land and sea without interruption. This makes it incredibly efficient for connecting distant places quickly. Speaking of speed, air transport is the fastest mode of transportation available, which is one of its biggest advantages. However, it's also important to recognize that this speed comes with a cost. Air travel is the most expensive mode, primarily because of the significant investments required in purchasing aircraft and building infrastructure like aerodromes. Lastly, air transport demands special preparations. This includes facilities such as Wheeler's Links, meteorological stations for weather monitoring, floodlights, and searchlights to ensure safety and smooth operations. These features highlight the complexity and the specialized nature of air transport, which is crucial to understand within the broader context of transportation development. Let's start by looking at the first point: high speed. One of the biggest advantages of air transport is its incredible speed. It's actually the fastest mode of transportation available today, which makes it especially useful when time is a critical factor. Whether you're transporting urgent goods or need to reach your destination quickly, air travel is often the best choice. Moving on to the second point: comfortable and quick services. Air transport offers a regular schedule, and the experience tends to be quite comfortable for passengers. It's efficient and allows for quick movement of people and goods, saving valuable time and energy. This is why many businesses and travelers prefer it for its convenience. Next, we see there's no investment needed in the construction of tracks. Unlike trains or ships, airplanes don't require extensive infrastructure like tracks or roads. This means less capital expenditure up front and lower maintenance costs, which can be a significant advantage for countries or companies looking to expand their transport options efficiently. Now, let's talk about no physical barriers. Air travel follows the most direct routes, which often means shorter travel times. Since it doesn't have to contend with mountains, seas, or forests in the same way ground or sea transport does, it can take more direct paths. This helps in reducing the overall journey time and increases efficiency. Finally, there's easy access. Air transport can reach places that are otherwise difficult to access, such as remote islands or mountainous regions. This makes it extremely valuable for delivering goods and people to areas that other modes of transport simply cannot reach easily or quickly. Together, these advantages highlight why air transport plays such a crucial role in modern connectivity, especially when speed, convenience, and accessibility are priorities. Now, let's talk about emergency services. One of the key advantages of air transport is that it can operate even when all other means of transport are halted, such as during floods or other natural calamities. This makes it the only mode of transport capable of reaching affected areas quickly to carry out relief work and deliver essential commodities like food, water, and medical supplies. Moving on to quick clearance, in air transport, customs formalities are generally processed very rapidly. This speed helps avoid delays, ensuring that goods and passengers reach their destinations without unnecessary waiting, which is crucial in emergencies or time-sensitive situations. Next, let's consider its suitability for carrying light goods of high value. Air transport is ideal for perishable items that need quick delivery, such as fresh produce or medicines. It's also perfect for transporting high-value, lightweight goods like diamonds or bullion over long distances, because it ensures safety and speed. Now, looking at national defense, air transport plays a vital role here as well. Modern warfare relies heavily on aircraft, which can quickly reach and strike targets, providing a strategic advantage. Airplanes can destroy enemy targets in a very short period, and they support the overall defense infrastructure of a country. Finally, air transport has contributed significantly to space exploration. It has helped scientists and engineers reach outer space, enabling us to explore beyond our planet and expand our understanding of the universe. All these points highlight how versatile and essential air transport is in various critical sectors, aligning with our overall theme of its importance in modern infrastructure and global connectivity. Air transport is known to be the costliest means of transportation. The fares are so high that, for most people, it's simply out of reach, making it less accessible for the average traveler. Another important point is its small carrying capacity. Unlike ships or trains, aircraft can't carry large or bulky goods economically, especially if they are cheap or heavy. This limits its use primarily to passengers and high-value or urgent cargo. Air transport also comes with a lot of uncertainty and unreliability. Weather conditions play a big role in flight schedules. Fogs, snow, heavy rains. These unfavorable weather conditions can lead to cancellations or delays, which disrupt plans and make air travel less dependable. Then there's the risk factor, breakdowns and accidents. Compared to other modes of transport, the chances of technical failures or accidents are higher, which makes air travel inherently riskier and more costly in terms of safety measures. Finally, the high investment required is another major disadvantage. Building and maintaining aircraft, airports, and infrastructure demand huge capital. Plus, operating this system requires highly trained and skilled personnel, adding to the overall costs. All these factors highlight why, despite its speed and efficiency, air transport has significant disadvantages that influence its overall use and accessibility. Air transport, as we've discussed, requires a very specialized skill set. It's not just about flying. It demands a high level of training and expertise to operate safely and efficiently. This means that only trained professionals can handle the complexities involved, which adds to the overall cost and skill requirements of air transport. Now, moving on to a different aspect, its suitability for certain types of goods. Air transport is actually not ideal for cheap, bulky, and heavy items. The main reasons are limited capacity and the high costs involved. Because aircraft have space and weight restrictions, shipping large, heavy, or inexpensive goods by air simply doesn't make economic sense. It's more suitable for high-value, time-sensitive items rather than bulk commodities. Lastly, there are also legal restrictions that impact air transport. Different countries impose various regulations to protect their own national interests, peace, and security. These restrictions can affect flight routes, cargo, and even the operation of airlines, adding another layer of complexity to international air transport. In the context of our overall discussion, Understanding these limitations helps us appreciate the strategic choices involved in air freight and how it fits into the broader logistics network. Let's take a closer look at airport classification. This slide highlights how airports are categorized based on different factors. Understanding these classifications is crucial because it helps us grasp the range of airport functions and their roles in the broader transportation network. For example, some airports are classified as international, meaning they handle flights across borders, while others are domestic, focusing only on within-country travel. There are also categories based on size and capacity, such as regional, major hubs, or small local airports. These distinctions influence infrastructure, services offered, and even the economic impact of each airport. So, recognizing these classifications allows us to better analyze airport operations and planning strategies. Overall, categorizing airports helps us understand their specific roles and how they fit into the global transportation system. Let's take a look at how different types of airports are classified based on takeoff and landing methods. First, we have the conventional takeoff and landing airport. These airports typically feature longer runways, usually more than 1,500 meters, which allow for standard aircraft operations. They are designed to accommodate larger aircraft that require more space for safe takeoff and landing. Next, we have the reduced takeoff and landing airport. These airports have shorter runways, ranging from about 1,000 to 1,500 meters. They still support regular aircraft, but with some operational limitations due to the reduced runway length. It's important because it allows air traffic in more constrained environments. Then, there are the short takeoff and landing airports, with runways between 500 and 1,000 meters. These are often used for smaller aircraft or specialized operations, like regional flights or private jets. They're crucial in areas where space is limited but still need to support aviation activities. Finally, we have the vertical takeoff and landing airport, which is quite different. These airports operate in a very small operational area, roughly 25 to 50 square meters, and rely on vertical lift technology, like helicopters or VTOL aircraft. It's a fascinating category because it enables operations in very confined spaces, often in urban or inaccessible areas. As you can see, airport classification depends greatly on the runway length and operational area, which directly impacts the type of aircraft that can operate there. This classification helps us understand the infrastructure requirements and the operational scope of different airports within the overall aviation system. Now, let's take a look at the different categories within aviation. First, we have civil aviation, which is all about the non-military aircraft used for various purposes. Civil aviation can be divided into two main types: international and domestic. International civil aviation involves flights that cross country borders, connecting different nations and facilitating global travel and trade. Domestic civil aviation, on the other hand, focuses on flights within a single country, serving internal routes and connecting cities and regions. Then we have military aviation, which is dedicated to the defense and security of a nation. Military aircraft are used for combat, surveillance, transport, and training purposes. Unlike civil aviation, military aviation is primarily driven by strategic and defense needs rather than commercial or passenger services. Understanding these categories helps us see how diverse and specialized the field of aviation is, with each sector playing a vital role in our interconnected world. This classification also highlights the different operational requirements and regulations that govern each type, which is crucial as we explore the broader scope of aviation in this presentation. Now, let's take a closer look at how reference codes are structured. They consist of two main elements. First, we have the code numbers, which range from 1 to 4. These numbers are used to classify the length of the available runway. Essentially, they help us quickly identify whether the runway is suitable for different types of aircraft based on its length. The second element involves code letters, which range from A through E. These letters are assigned based on the wingspan of the aircraft and the span of the outer main gear wheels. This classification is based on the ICAO standards, which ensure a consistent way of categorizing aircraft for safety and operational purposes. So, when you see a reference code, remember it provides a quick, standardized way to understand both the runway length requirements and the aircraft dimensions it can accommodate. This is crucial for ensuring safe operations and proper aircraft matching to the airport facilities. It ties into the overall theme of airport planning and safety, helping us manage aircraft and infrastructure efficiently. This slide doesn't contain enough information. That's why we're moving to the next slide. Today, I want to introduce you to the two broad categories of airports, which are essential for understanding how they're classified and managed. The first category is utility airports. These airports primarily serve general aviation, including private and recreational flying, and often support local communities and smaller aircraft. The second category is transport airports, which are larger facilities designed to handle commercial airline traffic, cargo, and passenger services, playing a vital role in connecting cities and regions. Now, when we look at FAA classifications, they often use these broad categories to help organize and regulate airports effectively. Recognizing whether an airport falls into utility or transport helps determine its design, infrastructure needs, and operational priorities. In the bigger picture, understanding these classifications gives us insight into how airports serve different functions within the national transportation network. It also helps us appreciate the diversity in airport types and their specific roles in supporting economic growth and mobility. Let's take a closer look at how the FAA categorizes different aircraft approaches. They define 5 approach categories, each based on the aircraft's approach speed. Now, this approach speed is not just any speed. It's specifically determined by taking the stall speed in the landing configuration and multiplying it by 1.3. Why is this important? Well, the stall speed here is measured at the maximum certified landing weight, which means we're considering the aircraft at its heaviest and most critical state. This approach speed helps us understand the aircraft's behavior during approach and landing, and it's crucial for designing safe and efficient approach procedures. Connecting this to our overall theme, understanding these categories allows us to appreciate how aircraft performance influences approach planning and safety standards. It ensures that pilots and controllers are on the same page when managing aircraft of different sizes and speeds. This slide doesn't contain enough information. That's why we're moving to the next slide. So, when it comes to geometric design standards, the FAA has a specific way of categorizing aircraft. They define these categories using what are called airplane design groups, and these groups are determined primarily based on the wingspan of the critical aircraft. That is, the aircraft with the largest wingspan that the airport needs to accommodate safely. Understanding these design groups is crucial because they influence the layout of runways, taxiways, and other airport facilities. Essentially, they help ensure that the airport infrastructure can handle the aircraft types it's expected to serve, maintaining safety and efficiency. This classification ties into the overall theme of airport planning and safety standards, making sure that every aspect of the design caters to the aircraft it will host, especially the larger, more demanding ones. The goal of a master plan is to provide clear guidelines for future airport development. It's about planning ahead to meet the growing aviation demand in a way that's financially feasible. At the same time, it's crucial to address the environmental and socioeconomic issues that exist within the community. As the FAA emphasizes, a good master plan balances these factors, ensuring the airport can grow and serve travelers effectively, while also being mindful of its broader impact. This approach helps us create a sustainable, well-organized development pathway that benefits both the airport and the surrounding community. This slide doesn't contain enough information. That's why we're moving to the next slide. When we talk about the airport master plan, we're really referring to the planner's idealized vision of how the airport will develop in the future. It's like a blueprint that outlines the desired form and structure of the airport's ultimate development. This plan isn't just about today's needs. It's about imagining what the airport could become over time, ensuring it can grow efficiently and effectively. Master planning is versatile. It applies not only when building new airports from scratch, but also when significantly expanding existing facilities. Whether we're starting fresh or upgrading what's already there, the master plan guides us through those complex processes. Now, the objectives of this master plan are key to understanding its purpose. They serve as the foundation for how we approach airport development, helping us align our efforts with long-term goals. We'll explore these objectives in detail to see how they support creating a well-structured, future-proof airport that meets the needs of passengers, airlines, and the surrounding community. Now, let's look at the key objectives for this part of our planning process. First, we aim to provide an effective graphical presentation of the ultimate development of the airport itself, along with the anticipated land uses surrounding it. This visual approach helps us better understand how the airport will evolve over time and how the neighboring areas will be utilized. Next, we're establishing a clear schedule of priorities and phasing for the various improvements outlined in the proposed plan. This step is crucial because it allows us to prioritize projects and implement them in a logical sequence, ensuring efficient use of resources and minimal disruption. We also want to present all the relevant backup information and data that are essential for developing a comprehensive master plan. This includes technical details, forecasts, and supporting analyses that underpin our decisions. Finally, we'll describe the different concepts and alternatives we considered during the planning process. Exploring these options helps us understand the reasoning behind our chosen approach and ensures that we have thoroughly evaluated all possible solutions before finalizing the plan. Together, these points form the backbone of our strategy to develop a well-informed, practical, and forward-looking airport master plan that aligns with both current needs and future growth. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. The selection of a suitable site for an airport really depends on the type of airport we're planning to develop. Different classes of airports have different requirements, so the site choice isn't one size fits all. When we look at major airport installations, there are several key factors to consider. These factors help us identify the most appropriate location that will support the airport's operations efficiently and safely. It's important to evaluate aspects like accessibility, topography, and land availability, among others. All of these elements come together to ensure that the airport can serve its intended purpose effectively. So, in essence, choosing the right site is a foundational step that influences not just the construction, but also the future operations and overall success of the airport. When we're considering the regional plan for the airport, there are several key factors to keep in mind. First, airport use is crucial. Understanding how the airport will be utilized helps shape the entire development. Next, proximity to other airports can influence traffic flow and logistical planning, so it's important to assess how close we are to existing facilities. Ground accessibility is another vital point. We need to ensure that transportation routes to and from the airport are efficient and reliable. Topography plays a significant role as well, because the land's natural features can impact construction and operations. We also have to be mindful of obstructions and visibility issues, which could affect safety during takeoffs and landings. Wind conditions are another critical factor, as they influence flight patterns and airport design. Noise nuisance is something we must consider, especially in relation to nearby communities, to minimize disruptions. Grading, drainage, and soil characteristics are fundamental for establishing a stable foundation and managing water flow effectively. Looking ahead, future development potential must be evaluated to ensure the site can accommodate growth. Availability of utilities from the town, such as water, power, and telecommunications, is essential for smooth operation. Lastly, economic considerations tie everything together. Understanding the costs and potential benefits helps us make informed decisions that align with broader regional goals. All these elements, when integrated thoughtfully, support a comprehensive regional plan that promotes efficient, safe, and sustainable airport use. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. Let's take a closer look at the parking and circulation area. This part of the design is crucial because it directly impacts how easily people can access and move through the space. Efficient parking layout not only enhances user convenience, but also contributes to the overall safety and functionality of the site. When we talk about circulation, we're referring to the flow of vehicles and pedestrians, ensuring that movement is smooth and logical. Properly planned circulation minimizes congestion and reduces potential conflicts between pedestrians and vehicles. It's important to highlight that a well-designed parking and circulation plan supports the overall theme of creating a user-friendly, sustainable, and accessible environment. By paying attention to these details, we help ensure the space is welcoming and efficient for everyone who uses it. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. Good afternoon, everyone. I'm Kay Rajendhuran from VEC, Chennai, and today I'll be discussing passenger facilities and services. When we think about modern transportation, providing a comfortable and efficient experience for passengers is fundamental. Firstly, passenger facilities include a range of amenities designed to enhance comfort, safety, and convenience. This encompasses waiting lounges, clean and accessible restrooms, and clear signage to help travelers navigate easily. In terms of services, we focus on punctuality, real-time information, and helpful customer support, which are crucial for building trust and ensuring a smooth journey. Highlighting the key point, The overall goal is to make every passenger's experience seamless and pleasant, encouraging more people to choose public transportation. Connecting this to the broader theme of sustainable and efficient transit systems, excellent facilities and services not only improve user satisfaction, but also promote greater usage, contributing to environmentally friendly urban mobility. So, in essence, passenger-centric facilities and services are vital pillars in creating a transportation network that is reliable, accessible, and welcoming for everyone. Thank you. Thank you for your attention throughout this presentation. I am Kay Rajendhiran from VEC Chennai. I hope the insights shared today have been informative and thought-provoking. Remember, the key takeaway is to always apply these principles effectively in our respective fields. Let's continue to innovate and improve, leveraging the knowledge we've gained. I appreciate your time and engagement. Thank you once again.